All right, let's go ahead and get started. I've got about a minute after 12. So good afternoon, everyone. Welcome to today's webcast. We are going to be talking today about climate change vulnerabilities and some resilient design considerations for stormwater BMPs. For those of you who have been following some of the other webcasts and materials that CSN has been putting out lately, we've been doing a lot on climate resilience. So today we're going to take sort of one specific look based on some work that we've done over the last year and a half or so, sort of an audio or visual companion piece, if you will, to one of the memos that we put out. So, you maybe have seen a little bit of this before, but this will be some of the more fleshed out version of some of that work. So for those of you who maybe haven't attended a webcast of ours before, just a couple of reminders. I'll have a couple of quick poll questions at the beginning, just to get a sense of who you all are, make sure I'm talking to the right group of folks here. And it gives us a sense of sort of our audience size and whatnot. There are a couple questions. If you're watching with a group, just answer the best you can for the group as a whole. We have sort of two options for Q&A today. There is a Q&A box which you can use to put your questions in. You can also drop them in the chat as well. I will do my best to keep an eye on those. I'll pause a couple times today to try to take some questions if you have them. We are recording the session right now, so we will have a recording posted if you aren't able to join for the whole thing. If you have to drop off, I'll try to get that up later this week. We also encourage you to share it around with other coworkers of yours who maybe weren't able to make it today. And then finally, we do have a really short evaluation at the end. It's only 3 questions, just to let us and our funders know that you like what we're doing, or if you have suggestions for things that we can do in the future, we'd love to hear that. All right, so let's jump right into the couple of poll questions. I'll launch this first one right now. This is just to tell us a little bit about yourself and who you're representing today. We like to know sort of what sector you're in. Are you working with a local government, in a private sector consulting group, state regulatory, federal regulatory agency, NGO, academia, or if none of these really describe you, please let us know in the chat. All right, thank you all. I will show you, we've got a pretty even split today, a lot of local government and private sector folks, and then a smattering from elsewhere. So we've got a second poll question. This one is just to tell us how many people are watching with you today. Now that we are starting to have folks back in their offices here and there, every once in a while we'll get a sort of a lunch conference room situation. So this just helps us capture how many people we're talking to today. So if we have any small groups, looks like we've got maybe 1 or 2. All right. I assume a lot of folks are probably still at home like I am today. All right. And then we've got one more poll question, and this is just to let me know sort of what your background or familiarity with this topic is. Basically, as I mentioned, we've been doing a lot of work in this area. So maybe you caught some of the runoff rendezvous panels on this topic. We had 2 or 3 that spoke to climate resilience. We have 4 different memos that are out on the topic. This one's going to focus on the 4th and final one. So if you've read those memos, I'd love to know that, or maybe you've done both of those. Some of you probably come at this from a little bit of experience, but maybe not related to CSN's work, or maybe you're new at it. So we love to know that as well. All right, so it looks like I'll share that with you guys. A little bit of everything. Some folks who have kind of followed along with some of the work that we've done, but most of you kind of come at it from a different perspective, or you've done a little bit of this work, but maybe aren't familiar with some of what we've done. So that's great. That means that you're in the right place. Hopefully what I can share with you today is helpful. So you just have me today. For those of you who don't know me, my name is David Wood. I'm the Stormwater Coordinator with the Chesapeake Stormwater Network. I did most of the work on these couple of climate memos with a great group of partners and stakeholders to kind of make sure that they reflected sort of what is the latest and greatest in climate resilience and BMP design work and vulnerability work. So I'll be sharing that. If you watch our webcast, you know that you see a lot of me So we'll have a bunch more webcasts, hopefully either later this summer or certainly in the fall. We'll be bringing in a lot of other speakers and experts as well. But today you're stuck with me. So I'm going to go ahead for the rest of the presentation today. You don't really need to look at me. I'm going to turn my camera off as I kind of go through the rest of what we've got going on. So this is what we're going to talk about today. As I mentioned, we have 4 different memos that are related to climate resilience and stormwater management that we did for work under the Chesapeake Bay Program Office. So I'll give a quick recap of the first 3 memos because they help to sort of set the stage, but then I'm going to really hone in on the 4th memo, which sort of was the culminating work that really looked at what are our vulnerabilities and risks associated with our stormwater best management practices due to climate change, and then some suggestions or ideas that we're going to start working towards in terms of longer term resilience to try to avoid or mitigate some of those risks and vulnerabilities. So I sort of have it set up today to kind of go through the urban landscape with a couple of different groupings of BMPs. So I'll talk a little bit about the overall framework that we'll use, and then we'll kind of go through from the upland LID practices through the conveyance network, talk a little bit about our ponds and wetlands and stream corridors and shoreline practices, as well as some of the other BMPs that are approved for credit under the Chesapeake Bay TMDL and what some of the implications might be for those. And then I'll wrap up with some resilient design considerations and some possible next steps that CSN is looking at, as well as other members of the Chesapeake Bay watershed region. So just again, to set the stage a little bit, there are sort of 2 tracks of this work. We have been working on this research and management synthesis piece. So these are the 4 memos. There are links to where you can find those at the end of today's presentation. I think I actually have them in 2 places. I think they're on the next slide as well, which is to really just pull together kind of current management practices that folks are using at the local and state level around the watershed to address climate change vulnerabilities with their stormwater infrastructure, take a look at what research has been done on climate projections around the Bay watershed, and then do this piece on vulnerability analysis. Meanwhile, I'm not going to talk about it a lot today, but there was a separate project that was funded by the Chesapeake Bay program and the Chesapeake Bay Trust to develop projected intensity duration frequency curves across the entire Chesapeake Bay watershed and the state of Virginia. So that work is actually wrapping up this week, and hopefully we'll be able to come back to you all with a full webcast from Rand and the researchers that were involved in that project to sort of make you familiar with that tool and how you might be able to use that in the future. So this is just to say that we are also going to have more information coming on sort of future precipitation in the Bay watershed and what that might mean for you. So these are the links to the reports. I'll just start with the quick recap of the previous work. Our first memo was focused on a stakeholder survey, right? So we spoke with about 200 different stormwater managers across the Chesapeake Bay watershed, both local government, private sector, state government, just to sort of get a feel for where folks were with climate resilience in general. Sort of what are the concerns, what is currently being done, and then what tools or resources do they want to see in the coming years. And so basically, I don't think a lot of these takeaways are super surprising, but basically everyone is really most worried about damage to critical infrastructure during large storm events. So transportation infrastructure, sewer lines, water lines, things like that. Obviously balancing the cost of doing repairs as well as routine maintenance comes up quite a bit as well. There is a general feeling that the stormwater design criteria aren't doing enough to deal with the changing precipitation patterns. And while all resources that we could put together would be useful to some extent or another, most folks really just kind of wanted to see all new design specifications or design manuals that could sort of address the entire picture, right? So rather than sort of a piecemeal approach, try to marry it together, pull in best design with future precipitation data and things like that to kind of get a full new set of design specs. So just to sort of back that up, this was one of the questions about the utility of the current engineering design criteria. So if you look at the number of responses, only 10 of our almost 200 respondents felt comfortable at this point in time with the current quality and utility of the engineering design criteria to deal with that future precipitation. The majority of folks felt that it was, not just important, but urgent that we get that information now. And on that cost piece, sort of it's not just the increased cost of non-routine maintenance, while that does stand out, but there's also these dueling priorities, right? The imperative of achieving both pollutant removal as well as dealing with sort of quantity control or flood control with sort of the same suite of BMPs, and how are we going to sort of pay to do both of those things at the same time as different practices have their own strengths and weaknesses. So sort of moving from that stakeholder survey, the second memo really tries to summarize the current design standards that are used across the Chesapeake Bay watershed. So we cover each of the different states as well as sort of the guiding principles that were used to put together each of those design manuals when they were done. What are the precipitation data sources that are being used to inform those design standards? What are some of the models that are used for modeling stormwater runoff through urban areas? So basically, the takeaway here for a lot of folks is that each of the states and the District of Columbia use slightly different design criteria. There might be some common themes, but they all have their own flavors. And then within those states and jurisdictions, there are further differences depending on the agency, right? The transportation agency might have slightly different design standards than the environmental regulatory agency. Federal facilities might be using something different as well. There have been some updates in recent years, but with one or two exceptions, sort of the latest round of sort of really a reimagination of these design standards sort of occurred in the 2006 to 2013 period. We've sort of been making tweaks and updates since then, but that was sort of the last wave of brand new manuals. And really why this is so important is all of these manuals rely on engineering design criteria that are based on historic precipitation data that's really unlikely to reflect future conditions. So that concept of stationarity, that the variability in precipitation is going to remain the same in the future as it has in the past, creates a lot of concerns for the long-term resilience of our stormwater infrastructure. The third memo gets into the review of the research that's been done in the last probably 5 to 10 years on downscaling future precipitation, right? So if we know that the precipitation in the past is not going to give us a good sense of what the precipitation will be in the future, we need to use our models to sort of figure out what that looks like. And then because a lot of those projections are done at these large global or regional scales, there are different methods that can be done to downscale those or try to make them applicable to a more localized area. So there have been 6 different studies that have been done across the Chesapeake Bay watershed. This memo summarizes those, talks about some of the methods that are used to do that, and why you might select one method over another. While those methods differ, there's a lot of similarity between the results. Generally, each of those studies found something between a 5 and a 35% increase in precipitation intensity between now and basically 2050, mid-century. So there's more on the way. As I mentioned, RAND had that study with Cornell and Carnegie Mellon to develop these at a station scale, but basically for every county in the Chesapeake Bay watershed. So we'll have that, and they looked at a couple of different methods as well, so in order to arrive at those results. We also looked in that memo, not just at precipitation, while that is usually what we're paying most attention to as stormwater managers. There's a lot more sort of consensus, I guess, around the range for temperature. We're looking at 2 to 3 degrees of warming over that time period, as well as 1 to 2 feet of sea level rise in that same period. And so all of this sort of comes together to, paint the picture of what our stormwater BMPs are going to be seeing in 30 to 50 years. And that's where it sort of leads into this vulnerability analysis, right? Because we take together sort of what our concerns are, what our current designs are, and then what these changing conditions will be to sort of pull together what those vulnerabilities happen to be. So we're looking at things like shifting vegetation palettes. more sediment in the contributing drainage area being mobilized, more rainfall volume sort of being concentrated in a similar number of events. So that's that intensity piece. Rising water tables, and at the same time, we don't have a great sense of the impacts on pollutant removal efficiency at this point. All right, so I'll do a quick pause. I don't see any questions in the chat at this point. If you do have them, please feel free to put them in the Q&A at any time, and then that way they're in there when we get to our next pause. But with that, I'll go ahead and start transitioning into the risk and vulnerability piece, right? So this is basically the framework that we wanted to use when looking at BMP risk and vulnerability. The idea here is that these challenges can happen on a range based on the impact to human health and safety, all the way down to things that might be anticipated to fail regardless of climate change. So we're looking at this, specifically in the lens of climate vulnerability. But there are obviously factors such as the age of the practice, the location of the practice in the watershed, and the existing maintenance or design condition that are going to sort of play a role in terms of where something might fall on this spectrum. Climate change is really sort of the exacerbating factor here, but a lot of sort of the underlying issues that lead to those vulnerabilities sort of exist outside of the lens of climate change necessarily. So, at the high end, we've got catastrophic failure, where the practice, fully blows out, resulting in a very direct risk to human health and safety. Kind of working our way down, there might be failures that are structural, but there aren't those same safety implications. You might lose the performance from a water quality perspective, or have a failure that results in some sort of a downstream impact to a stream corridor or something like that due to failure. It might not be a total failure, but you start to lose some of that efficiency in a BMP over time. And then, as I mentioned, some of those that might be anticipated otherwise. So, talking about that age and maintenance condition, I just want to make sure that we mention that there are several non-climate related effects on BMPs, including, continuing development and changes in land use. There are some studies that are showing that while the balance is shifting, there are still sort of greater effects from that land use change over time and increasing urbanization than climate change at this point. That is, like I said, sort of shifting as climate continues to change. That balance is going to continue to tip in the other direction. But, then there's also just the existing condition, the maintenance condition of these practices, right? So there was a study done about 10 or 15 years ago now, about 200 BMPs in Virginia were studied, and 46% of those practices were found to need maintenance. And the treatment was deemed to be ineffective in over a third of those practices just due to design flaws in the BMPs. Now, things have improved a lot since then. There is much more robust operation and maintenance procedures. There is BMP verification in the Chesapeake Bay watershed that is helping with that. But just as these practices age, there's natural wear and tear. And so, even at this point in time, based on records that we have from localities and from states, for BMPs that are reported to the Chesapeake Bay program, there is still sort of a failure or an expiration rate that ranges somewhere in the 5 to 15% of reported BMPs, sort of in a 10 to 15 year time frame. So just something to be aware of, that these things are struggling a little bit just because of natural age and changes in the watershed. Also related to age is just the typical timeline of the progression of stormwater infrastructure. So this is really important when you're thinking about prioritizing where you need to kind of go back and look at potential vulnerabilities in your systems. Looking back to the 1960s and earlier, most of our neighborhoods built in those, in that era were conveyance only. There wasn't really much in the way of detention or storage. We were just moving the water out of the streets and transportation areas and away from buildings as quickly and efficiently as possible. Moving into the 1980s, we sort of get into that pond era. So we usually refer to these as our legacy ponds. A lot of them are still around, providing some level of quantity control, although they're not doing much for water quality. And then as we got into the 90s and early 2000s, we started to balance, water quality with water quantity until we sort of got to where we are now, which are these distributed, low impact development, green infrastructure practices, and more recently, a lot of stream restoration as well. So, depending on the objectives, it's going to affect, what those vulnerabilities may be. And then also just knowing when those developments happened are going to tell you a little bit about how they were sized, what precipitation data were they using at the time when they built that detention pond or something like that in the 1980s. So, just sort of something to keep in mind for your prioritization work. So the rest of the talk is really going to kind of hone in on this location-based framework, right? So we've got our urban stormwater drainage network where we sort of go from our upland areas with our sort of dispersed flow, where we have these distributed LID practices with relatively small contributing drainage areas. Some of them might be online, or in other words, in the flow of the natural runoff path, but a lot of those tend to sort of be offline practices. Then you sort of move down into the conveyance network as it starts to concentrate in flow. Then we sort of have our ponds and wetlands, which have the largest or the larger contributing drainage areas. They collect a lot of the runoff that sort of flows down through those conveyance networks and then eventually to our stream corridors. So we're going to sort of work our way down, starting with these upland LID practices. So in a lot of ways, these practices are at a lot of risk for sort of routine maintenance needs and loss of functionality, right? They're less likely to have some sort of a catastrophic impact, but they are sort of inherently maintenance needy practices. They're primarily designed for water quality, so they're sized a little bit smaller. They're not meant to sort of handle that 100-year storm event. But because of that, they have quite a few vulnerabilities to large, intense events. And that's, erosion, both at the inlet and at the outlet of these practices. They are really subject to sort of bypass and overflow because of the way that they're designed and the intention to sort of capture those water quality events. So if we have more water that's being concentrated in the same number of events, we're going to see a lot of that additional flow, bypassing the system altogether. Seeing that increased mobilization of sediment in the contributing drainage area also means that we're likely to see more clogged filter media that can really have an impact on performance, as well as distressed vegetation that could be due, either to the more extreme precipitation regimes, longer periods of drought, longer periods of intense rainfall, but also, things like changing temperature conditions and things like that as well. A lot of these vulnerabilities can sort of tie back into just, design flaws or maintenance conditions that, again, are just sort of made worse by climate change. Things like improper design elevations, really steep curb cuts and things like that might lead to, really intense erosion pretty quickly if we have more intense storm events in the future. These intense storm events also tend to create these preferential flow paths through the facility, creating erosion. This can be caused by undersized curb cuts as well. Again, so as those conditions change, we get more intense events. We might need to be thinking about how we're sizing those curb cuts, how we're locating them, what are the drops in elevations and slopes from those curbs into our bioretention facilities and things like that. And then do we have, insufficient pre-treatment to capture maybe that additional mobilized sediment from the contributing drainage area? And do we have ways of allowing that excess flow to bypass our systems without blowing them out, right? Do we have a way to sort of let them go by, whether we set up some sort of a treatment train or something similar to try to deal with that without creating longer maintenance headaches? Also related to location, I'll talk about tidal flooding impacts here, although it really affects sort of each of these groups of practices. Tidal impacts are going to really influence whether you can even use some of these LID practices. As we have sea level rise in some of our lower lying areas of the watershed, we are getting this elevated groundwater that's reducing the infiltration capacity of our practices, maybe, making infiltration BMPs, taking them off the table, basically. So, we also are looking at things like submerged outlet structures that are backing up capacity in our systems. That's maybe particularly relevant in our conveyance networks, but in some cases in some of our LID BMPs as well. And then saltwater intrusion affecting the types of vegetation that we can plant in these practices, and pollutant removal as well. There's some evidence that large amounts of salt getting into these systems can reduce the phosphorus removal effectiveness of LID practices. So, that I think has been studied in some ways relative to road salt impacts, but it's relevant in terms of tidal influences as well. So getting into the water quality performance, because this is a concern certainly for LID practices that are usually designed for this purpose. The good news is, for folks in this area, most of these water quality BMPs are designed to capture and treat the 90th percentile storm event, which hasn't changed all that much. We did sort of a preliminary look using precipitation data from Reagan National Airport in DC, and found that the 90th percentile storm had only increased by about 6% in the last 15 years. If you consider sort of error bars and things like that, that's a pretty insignificant amount of change. Some work by John Butcher last year found basically the same, looking across sites in Maryland. The predicted intensity of that 90th percentile event isn't consistent across most of the state of Maryland. So, again, we're not seeing much change there. But that doesn't mean that there won't be sort of water quality performance impacts on BMPs, because a lot of that additional volume is coming in those more intense, those larger storm events. So basically a lot of the additional flow or the additional loads are going to be sort of untreated. They're going to be going around our BMPs as they're currently designed. So this is a summary of some of the pollutant removal impact studies that have been done. It is obviously really difficult to study how climate change is going to impact BMP performance in the future, because it's difficult to simulate the future in the field, right? So there has been a study that sort of used extreme weather like hurricanes and large intensity events as a proxy for climate change to look at their impact on bioretention. And found basically there is a pretty significant uptick in bypass during extreme events, 40%, and then even 23% bypass during the non-extreme events. So, this is, a lot of it has to do with the effectiveness of the inlet systems. So the same research team was sort of looking at those inlet systems for these LID practices, sort of Green Street bioretentions in this case, and found that the increased runoff was decreasing the inlet capture efficiency. So basically, the more intense the precipitation got, the less precipitation was making it into the BMP itself, and it was just sort of going around it. Some of these other studies have done modeling approaches, sort of simulating future climate conditions through things like the SWIM model or other stormwater management models. And all of them found some degree of loss in performance due to climate change, ranging anywhere from, maybe 0 to 15% loss in pollutant removal efficiency, to something pretty extreme in the case of the overflow modeling that was done in North Carolina at the Hathaway study. So, the reason for these changes isn't super well understood at this point. It's understood to sort of be a combination of bypass, higher influent concentrations, changes in antecedent moisture conditions in the BMPs, but we're still trying to understand why this loss is happening in these cases. So shifting sort of to the next stage in our drainage network, looking at conveyance practices. These are a little bit different because a lot of these conveyance practices aren't in place for water quality purposes, but they are very closely associated with our transportation infrastructure. And in a lot of ways, vulnerabilities here can create problems for some of our BMPs that are meant for water quality, because they can serve as a choke point that elevates risk elsewhere. So, if we have in some of our softer practices, maybe our swales and things like that, erosion can, lead to an issue if they're designed to sort of be non-erosive for the 10-year storm, but now that storm size is increasing, we might start to see some erosion in some of those practices, as well as sort of getting the water getting from the streets into and out of those systems, like at outfalls and things like that. We're also seeing some loss of capacity in these systems. That could be due to undersized piping based on the age of these conveyance networks. Because remember, a lot of these systems were the ones that are oldest within our system, maybe designed or built in the 1960s or before. So in those cases, maybe using precipitation data that's as old as, 70 to 100 years old at this point. They're also filling up, right, with either tidal, backups in some of our lower lying areas, or by mobilized sediment, sort of filling up the bottoms of those systems as the more intense events carry that sediment into our conveyance networks. So I sort of alluded to this, but some illustrations of what this can look like here, right? Some of our rural roadside ditches or our lesser engineered practices are particularly vulnerable. They tend to be, and in some cases, scraped out, making them really vulnerable to erosion in these higher intensity events. But again, sort of that choke point is illustrated in the picture to the right, where, eventually if the pipe is undersized, you're going to get backups, and it might impact the performance of your practices upstream or upland of those systems. Continuing our move down the watershed, we've got our pond practices. These, again, maybe are the highest risk of, in terms of our framework, our vulnerability framework, because they have such a high impact on public safety. They are meant to hold a tremendous amount of water. They're meant for quantity control. A lot of times they are built sort of, near large residential communities and things like that, where a dam breach or something like that can be very catastrophic. As I mentioned too, aside from the conveyance network, they are our oldest practices, certainly, in terms of the ones that are meant to provide at least a little bit of water quality performance. A lot of these ponds now in the Bay watershed are sort of dated to the 1980s or 1990s, so they may be undersized. Those vulnerabilities, a lot of them, again, erosion is going to be a common one that you see, obviously, in a lot of these. Same with sedimentation, as we lose capacity in these systems as it sort of settles into the bottom, unless they're dredged regularly. Again, maintenance is getting better for a lot of these practices, but it can be expensive. It can be a pain to haul away or to dredge some of these ponds to restore that capacity. Emergency spillways obviously cause the greatest risk in terms of public safety. So making sure that those are intact and up to the challenge of sort of the higher level storm events is really important. And then from a water quality standpoint, leaching and resuspension, I'll talk about that a little bit more detail on the next slide, or the one after this, I suppose. So this is just some illustrations of some of these impacts here in terms of the vulnerable design elements. On the water quality side for ponds, again, focusing mostly on sort of our wet ponds, since the dry ponds don't offer too much in the way of water quality as it is. Basically, when it comes to extreme events and climate change, the high flows with these really intense events can really disrupt the settling processes in these ponds, especially the shallower stormwater ponds. They kick up a lot of that sediment and remobilize the ones that have settled at the bottom, kind of creating that resuspension so that they can leach out. So it shortens that hydraulic residence time within the ponds during those extreme conditions. There's also a loss of efficiency, just in the sense that these high flows carry a lot more loads with them, much higher concentrations of pollutants. And a lot of times these ponds really struggle with those high concentration events. And a lot of that is going to kind of move right through the system without a lot of settling and treatment. All right, so getting into some of the non-traditional stormwater practices, but some that are used quite frequently around the Chesapeake Bay watershed. We wanted to talk a little bit about stream corridor and shoreline restoration practices. In a lot of ways, they are the most, online practices that we have right now that we're sort of using or doing restoration within these stream corridors. They have the largest contributing drainage areas, right? It's the sort of the endpoint for, all this runoff that's happening in our upland areas. So they're experiencing a lot of flows, and they're generally designed to withstand floods, right? While there are some floodplain reconnection practices that can help dampen hydrographs and things like that. They're not really meant to be an infiltration BMP, right? They're not slowing down the floods in that sense. So, these practices are vulnerable, particularly the more structural elements, the harder elements of some of these practices. But then we're also expecting sort of increased bank erosion and things like that with both shoreline and stream restoration practices. So, when it comes to stream restoration, I mentioned sort of the structural elements. There's been some work, granted it's a little bit dated at this point, from back in about 2000, and the profession has evolved quite a bit since then. But, 20 to 30% of those structural techniques have been shown to experience some degree of damage or loss of function over time. A lot of that is due to sort of design issues up front, right? Inaccurate predictions regarding the design parameters, things like the width, depth, the radius of the meander, things like that, or maybe poor reference site selection. If you don't have a good reference site chosen, you might size your channel, not appropriately for future climate conditions and things like that. So while the design principles have shifted, the impacts of climate change are still not understood in a stream restoration context because it is so new as a practice or as a BMP. There has not been a lot of work at this point to study the implications for stream restoration. Because they are so heavily relied upon for TMDL reductions across the watershed, both for nutrients and sediments, we do sort of need to better understand the water quality performance impacts. There's almost no research on those changes. Theoretically, there is actually potential for increased load reductions based on the stream restoration protocols. Because those protocols are sort of based on a change from pre-restoration to post-restoration conditions, if you think about it in the sense that higher flows, more intense flows are likely to increase bank erosion rates before restoration, sort of worsening the conditions of some of these streams in the short term. That means that a restoration on some of those really degraded sites is going to yield greater benefit over time. That said, that's sort of the paperwork piece of it, right? And those gains could very easily be offset by a single extreme storm event. I'm sure a lot of folks are familiar with stories of practices, stream restoration practices that have been blown out by particularly aggressive, storms and things like that. So it's just something that we need to be really aware of, and probably an area that requires some future study in terms of how we're designing these practices. How resilient are they? Are there different techniques or approaches that are more or less resilient, and what are the implications for water quality performance? I'll quickly just touch on some of the other urban stormwater practices. There is almost no data for some of these other BMPs. This includes things like street sweeping, urban nutrient management, nutrient discharges from gray infrastructure. Those are all sort of programmatic types of practices. Again, we can sort of do a theoretical exercise with those, with street sweeping. Does changing build-up and wash-off dynamics with increasing precipitation intensity have an influence? Same thing with sort of our high-risk lawns for urban nutrient management. Are some of those exacerbated if we have poor vegetation or ground cover in some of those high-risk erosion areas? But those aren't backed up by research studies and things like that. The tree BMPs, urban forest planting, urban tree canopy, riparian buffers are a little bit better understood. But again, they're lacking data. We're talking about things like we know that the tree species are, their ranges are shifting over time. And so how does that change what, species or trees we're going to use in our buffer plantings or in our urban settings? Are mortality rates changing over time because of those shifting ranges? Are the trees that we planted 10 years ago starting to die off because of changes in temperature or maybe rising water tables along our riparian corridors? So, that's a lot of information relative to, the vulnerabilities. So, I went through a lot of information there to sort of touch on what those vulnerabilities are. I'm going to pause for a second. I'll try to answer a couple of these questions that have come into the Q&A before we get into the resilient design considerations. Bear with me. I'm going to sort of read these questions aloud as I sort of go through these. So a question from Deborah is, one of the RAND studies looking at not just total rainfall, but shorter duration rainstorms and higher volume of rain during those periods. Since current standards seem to focus on a 1-inch rainfall, they cannot withstand the 2 to 3 inch rainfalls that have occurred in recent years in Maryland. So to answer your question, basically what RAND has done, their downscaling study does a really nice job for events that sort of range from the 1-year storm or the 2-year storm all the way up to the 100-year storm event, projecting those. They do that for different emissions scenarios, so RCP 4.5 and 8.5. One of the challenges with downscaling is it's really difficult to get to the temporal resolution that you need for really localized stormwater modeling. So some of your H&H modeling, hydrologic and hydraulic modeling. So there are methods, and they recommend some for sort of filling out the lower range of your IDF curves down to the 10, 15 minute duration events and things like that for those really short bursts of intense rainfall. They feel pretty confident in the methods that they have. So they'll have documentation on that within their tool to sort of help address some of those questions. That said, there are still concerns, again, about some of those really hyper local burst events that have occurred. I know Baltimore has had a few of those where one side of the city is seeing several inches of rain and the other side of the city is seeing half of that. So there is still some work to be done to sort of fine tune those models for certain applications. But I think there are some methods, if we want to start looking towards implementing new sizing guidelines or sort of best practices for improving the resilience, I think some of those tools are in place now. Another question, aware of increased wind-driven events studies recent or anticipated for our region, and does the wind-driven aspect cause additional stress on stormwater systems? That's a good question. I think that some of the coastal communities that have done localized studies, for instance, in the Hampton Roads, Virginia Beach area, I believe that they did some work that incorporated some wind effects as well. But I admit that I'm not super familiar with that. So I would have to kind of dig back in because there would be some wind-driven elements in terms of probably, the sunny day flooding and some of those tidal flooding elements that would affect the conveyance and some of the lower lying BMPs in those areas. I think that would probably be the most likely impacts and effects there. And then one other question from Deborah, some Chesapeake Bay areas are focusing on high density development, but doesn't that present a problem for conveyance and ponding systems that were not built to sustain higher density? How can this be dealt with by education of government entities charged with encouraging high density development? So it's a good question. Certainly, we are worried about the combination of, changes in land use as well as, the changes in precipitation and climate over time. The way that most of the sizing criteria are developed, there is a standard in place for new and redevelopment for capture and treatment. while the concern remains that they are based off of historic precipitation data. And I think we're moving in the direction of sort of updating that to look either at newer sources or even projected precipitation in our design. There are some protections in place as we increase density in some of those areas, but it is certainly something that we need to look at. And so part of the reason for this work is, of course, to sort of make folks aware of, what some of these concerns might be as we deal with increasing precipitation intensity in the future. All right, so I'll just quickly, I have a couple of slides here before we wrap up today. We'll be done by 1 o'clock on resilient design and next steps. So this is sort of our forward-looking angle. So we've laid out all of these vulnerabilities, and we're still sort of in the idea generating phase at this point, right? We have some good basic principles, but there's still some work to do to sort of get these to implementation or application phases. So we laid out in this memo a series of 6 different resilient design principles that we hope to build out. One of those, is comprehensive watershed management. And that's sort of a buzzy type of catchphrase, right? But it basically means making sure that we're working across all of the relevant agencies, not just thinking about stormwater management sort of in a silo, but how does it affect our floodplain management, or our dam safety agencies and transportation agencies. Meanwhile, what are the impacts on, stream restoration or our stream corridors? How are we sort of implementing stream restoration in combination with upland practices so that, future intense storms don't blow out something that we've invested a lot of money in? At the same time, it also brings in sort of the people part of it too, right? Resilient communities mean a lot more than just sort of stormwater infrastructure, but are we doing these in a way that is equitable and considerate of what the conditions are in the neighborhoods and the communities that we're trying to do this work, right? So that's the comprehensive watershed management piece. Sizing, I've talked about quite a bit already, and I'll have another slide on that in a second. The concept of flow plains is sort of designing our infrastructure and our stormwater conveyance so that overflow and bypass sort of has a safer place to go. We think of floodplains for streams, but do we need to think about how can we direct water to safe places in the communities when they overflow or bypass our other treatment practices and things like that? Is that something that we need to look at? There's been some work done in Europe, in New York City and other places with sort of these stormwater park type systems where you're storing water maybe in a on a basketball court or somewhere else in the community that is sort of designated as this sort of flow plain concept. Full cycle implementation really means how do we bring a lot of attention back to maintenance in the context of climate resilience. A lot of these issues or vulnerabilities can be dealt with through routine maintenance, regular maintenance, but do we have the funding for that? Do we have the procedures to sort of catch the types of vulnerabilities that we're expecting to have? Do we have redundancies built into the system? If something fails, is there something backing it up? If we're losing treatment or we're getting more bypass from sort of our first line of defense, is there another practice sort of in line to capture some of that might have missed our first BMP or gone around it or overtopped it or something like that? And then performance enhancers, these are just sort of design changes, things like media amendments like biochar or iron fillings or internal water storage that are sort of already known or talked about that might provide a boost in pollutant removal performance or capture. By these practices, it might provide a little bit more of a buffer or a safety net if we do start to experience loss in efficiency or performance because of climate change. So this is something that we can kind of proactively do now to try to help offset any long-term effects of these changes. So to just build on the sizing point, a lot of people think about sizing as just replacing the IDF curves, and that's certainly an option, but there are a couple of different ways that you could look at if you wanted to look at revising your sizing criteria. Some communities have approached it differently, albeit most are sort of still in the exploratory phases now. So as I mentioned, You can take these projected IDF curves, for future years and use them as IDF curves. There are options for sort of extending them down or scaling them to those lower temporal resolutions. But we do lack a lot of that resolution for a number of design applications. And I understand that there are going to be some hesitancies, as you understand the uncertainties around some of those curves and things like that, to not just sort of copy paste them and use them in your manuals. So there are other approaches. You can look at sort of a factor of safety approach. Maybe that is looking at a change factor between Atlas 14, the current precipitation data, and a projected condition, and sort of add a percentage to your Atlas 14 curves based on those numbers. You could do something like increasing the design storm criteria. There have been some studies that say, well, the 100-year storm is now really the 66-year storm event. So you could think about those types of scaling practices and say you want to design, for conveyance to, handle the 15-year 24-hour instead of the 10-year 24-hour. And then there's sort of over-management criteria as well that are an option. So these are just some things that are on the table. I'm sure that as we kind of go down the road with this and we've had some more time with the projected precipitation data, some recommendations will start to emerge. We'll see some more case studies with communities that have worked with some of these options to see what is most palatable, most appropriate, and provides the most resilient designs in a cost-effective manner. I won't spend a lot of time on this because I talked about the full cycle piece as well. But we've sort of presented this concept in the past, full cycle BMP implementation. You have, monitoring objectives and assessment objectives for your practice, knowing sort of upfront what it is you want to achieve with your BMP, whether it's a certain amount of pollutant removal performance or a certain amount of capture for water quantity control or flood control. Making sure that those objectives are known up front so that you can adjust your design to meet those needs, and then also have a way to sort of, as you go through your inspection, maintenance, and makeover plans, to know, when have you fallen short of what those objectives are? What are your thresholds for that? So, thinking about maybe building maintenance targets or, specific performance objectives into your inspection regimes or into your designs or design manuals is something to consider. There's also opportunity for changes to our specifications. I sort of alluded to this a little bit throughout the presentation today, but the inlet is an area that I think is really ripe for some redesign potential. They can be a maintenance headache if you think about some of the cobble types of pretreatments and inlet designs. The curb cuts tend to be, maybe undersized, or, because they're offline, a lot of water is they're maybe perpendicular to the flow of water. And so the water isn't getting in, especially in those larger events. So how do we, redesign them or try to standardize the inflow to make sure that they're functioning the way that we want them to? Do we have sustainable landscaping templates? As temperature changes, precipitation regimes change, the plants that we put in place might need to change. And that includes mulch. We're sort of moving away from the mulch model as they create a huge maintenance headache. So any way that we can try to reduce those, routine maintenance hurdles to sort of free up our time and energy to dealing with some of these, climate affected maintenance concerns, I think that's a plus. I mentioned the maintenance benchmarks and the performance enhancements as well. I think there's also still work to be done on coastal design adaptations. There are, pump systems and things like that that are in place, but I think there's still some work to be done in that area to try to provide some cost-effective solutions for coastal BMP design. So in terms of next steps, this memo recommended some potential areas to explore for the Chesapeake Bay program partnership. I won't go through all of those today since you're not quite the same audience, but there are basically recommendations to continue gathering data on BMP performance impacts. So I mentioned the couple of practices where there are still there's a lack of data available, things like stream restoration, shoreline management. street sweeping, urban nutrient management, some of those practices where they are being used around the watershed to meet TMDL and MS4 permit requirements. So we want to understand what the impacts are. We also are ready to start moving towards implementation. We've kind of done all of this work to synthesize where the research is. It doesn't mean that the research questions will stop. We'll continue to have those and we'll continue to explore them. But I think we have enough evidence at this point, and some ideas about how we can be more resilient in our design and our watershed planning to start, walking down that road. So maybe that is, effective new state or bay-wide stormwater design standards and specifications to address new precipitation data sources, or even some of these other, performance enhancements or design adaptations to deal with maintenance or vegetation. Working to develop better partnerships and discussions to coordinate between relevant state agencies to make sure that there is, the proper channels between dam safety and floodplain managers and the folks in charge of stormwater. And then, providing updated guidance for some of the impacted BMPs. Are there new plant palettes that we're recommending or new species for riparian buffers that we want to be recommending? If we make changes to the design specifications, do we need to update the retrofit or stormwater performance standard BMP expert panel reports? These are sort of questions that we're going to start looking towards in the future as we move towards implementation. All right, so that was a lot of information. We got in just under an hour. I'm happy to take any questions that you guys have at this point in time. While you put those in, I will just mention that, if you wanted any more detail or sort of need to digest this a little bit differently or in another way, we do have a memo that walks through all of these recommendations. I put the link in earlier. I have it in a resource slide here in a moment as well. Here are the resources here. There are also a couple of webcasts that we've done in the past on this topic as part of our Runoff Rendezvous event. We had one with a panel of really great folks talking about climate change and extreme precipitation, a little bit more detail on some of those inlet concerns, a little bit of information on, the RAND tool on the projected curves, as well as sort of dealing with equity considerations as well when we plan for more resilient communities. And then sort of how we're dealing with the design shift or the paradigm shift rather from water quality, maybe back to flood control a little bit more with these events as well. So if you're interested in those are all posted and available for free for you guys to check out. We did have a question come in. Are there any planned upcoming discussions or strategies with state agencies to update specifications and design requirements with this and other study results? And are there ways that people on this call can assist with that? So that's a really great question. So each of the state agencies have been engaged with this effort. They are members and participating members on the Chesapeake Bay program's Urban Stormwater Work Group. So they have all seen this presentation. They were involved in sort of signing off on the memo, as well as reviewing the RAND tool, the projected IDF curves. So we're sort of in the process of putting these resources in front of them. Our hope is to have sort of a workshop or a meeting of the minds with each of the states in the next 6 to 8 months, hopefully. That is sort of in the idea phase at this point. There's nothing actionable right now, but our hope is to sort of start moving towards providing tools and options for those states. There is a level of each state will probably take the guidance and fit it within their existing programs and manuals and regulations and things like that. So our goal is to just provide them with the resources to help them with that process. As far as ways to help, if you are interested, you can reach out to me via email. I can put my email in the chat in a moment if you don't have it. And if we do have future workshops or events that are sort of open to the public in terms of, talking about some of these issues, we can make sure that you are aware of when those are happening. All right, so what I'll do, I will back up 1 second. If there aren't any other questions, we do have this survey. I would really appreciate if you guys would take a moment to fill this out. I'll put it in the chat. I'll type that in right now so that you can link directly to it. It's just 3 questions. So it'll only take you a moment. We really appreciate the feedback that you have on today's presentation. If you have ideas for other topics that you want either around climate resilience or other webcasts that we could feature in the fall on any stormwater related topics, please let us know. We always are looking for your suggestions to make sure that we are meeting your needs. With that, thank you all for sticking with me. I know it's a little bit tough to listen to sort of one person talk for about an hour, but hopefully this was helpful to everyone. I really appreciate you all joining. I hope you can share this with your colleagues if you found it helpful. With that, we will wrap up for today. So thank you again. Just be on the lookout in our Stormwater Scoop newsletter and on our website for all of our future webcasts. Hopefully we'll have a couple more announcements on that in the next month or 2.